In this exercise, we will develop a simple program that applies the knowledge that you have learned in the previous lectures in order to make the robot move and also display its position. So, to make things simple, we're going to use the Turtle Sim simulator, and the principle is the same if we work with any other robot. So, you need first to start the simulator. First of all, you start with ROS core, and then you open another terminal and you run ROS run Turtle Sim and Turtle Sim node. So you will have the Turtle Sim simulator. So now what we want to do, we want to develop a program that will publish command to the Turtle Sim to make it move for a certain distance, and also that will subscribe to the topic that we provide as with the location of the robot, the position of the robot. Okay, so what you can do, you can open Visual Studio Code, and here in the SRC folder, you can create a new folder. Let's call it assignment, this folder. And then you can create a new file. Let me call it robot move topics.py. So you can develop in Python, or you can also develop in C++. Okay, so basically here we need to develop a subscriber in the same program code. So the same node will act as a subscriber for the topic that will show the location of the robot, and will be a publisher to the topic that will make the robot move. Of course, the first question is, what is the topic of the position? And what is the topic that makes the robot move? So we need to find the topic names. Of course, the usual way that we can do it is to use ROS topic list. And here you will have the list of all the topics available. So it is clear from previous lectures that the topic pose will represent the position of the robot. And the topic cmdvel, it means command velocity, it represents the topic that will make the robot move. So what you can do, you can actually take any of these two scripts. For example, I'm going to start from the listener script. Well, let's start from the talker script. I'm going just to copy it exactly the same. And then we will make necessary changes. So of course here you need to change the type of the message, because in this case you're not going to publish on the string message. This was the case from the publisher subscriber simple application, but here we are going to publish on the topic cmdvel, which is going to contain information about the speed. So first thing I can change, for example, I will change cmdvel here instead of the shutter. So I will create a publisher, let me call it speed publisher. Okay, it's going to be a publisher on the cmdvel topic. Okay, and later on I have to see how to publish. So I will change this later. You need to change this later. But now, the second information here, so this topic is not of type string, so I need to know what is the type of this topic. So remember from a previous lecture, we have used ROS topic info. Okay, and ROS topic info allows us to find what is the information about this topic. And one of the information, it gives us the type of the message that is used by this topic. So the type of the message here is geometry msgs/twist. So twist is the message of our interest. So this information is useful for us in the code, because now we're going to change this from statement with another one from, so geometry msgs dot msg import. So we will use the twist message. So the twist message contains the information about the speed of the robot, whatever it is, the linear speed or the angular speed. Now the question, what is the content of this message type? This is something that you have to know. So just to give you another hint. So remember from the lecture where we talked about an introduction on ROS topics, ROS node, and ROS messages, we have used the command ROS msg show, and then we can supply here the type of the message that we want to see its content. Okay, so look here. Now, this twist message, it contains two components, one that is linear for the linear velocity, and the second one that is angular for the angular velocity. And here linear velocity has x component, y component, and z component because any motion occurs in three-dimensional space. In the case of turtle scene, we have only two-dimensional space, x and y. But for example, if you are flying a drone, we will also have the z component that with respect to the altitude. Okay, so on the other hand, we also define the angular velocity, that is the rotational speed or the rotational velocity, which is also defined in terms of x, y, and z coordinates. Okay, so you must know how to use this information in your Python code in order to define the velocity of the message. For example, now I can give you some more hints. Okay, so let's say we want to define a new velocity message. So let me define it as twist object. Okay, this is the way, and then what we can do, so we define a twist object, and then inside the twist dot, so we can select linear dot x. For example, I want to make the robot move forward, so I can assign a value 1.0. And of course, I can do other assignment for the angular velocity and linear velocities. So try to think about this in order to modify this talker method, and you can make it, for example, move method. Okay, and so you need to make necessary changes in order to publish the twist message correctly. So try to think about this exercise, and later on you can see the solution that presents you can watch the video that presents the solution. Just a final comment before start working on the exercise. Do not worry if you feel that you are facing a lot of difficulties, because this is normal for new ROS users, and later on with the explanation you will be able to understand more and more the concepts. But before looking at the solutions, try your best to solve this exercise, and later on have a look at the detailed solution video.